This is TWIS, This Week in Science, episode number 941, recorded on Wednesday, August 30th, 2023. Why are German boars so hot? I'm Dr. Kiki, and tonight on the show, we will fill your head with boars, bees, and bats. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. The world is complicated. Filled with complicated things. If something seems simple, it is likely a reflection of your perspective. Add a few layers of inquiry into anything. Question why it is the way it is. How did it get that way? Why does it do what it does? Does it do anything else? What other things is it connected to? Are they connected? And why does the other thing do the things it does, and what else is it connected to? And how did it get that way? It's okay to ask questions. For the most part, you can live a long, happy life without questioning too many things, but every once in a while, you will come across something. Something interesting, like a news story. Something important, like a diagnosis. Or something that just keeps you up at night, like how the concept of object permanence seems completely lacking in quantum wave functions. Sigh. So, you decide to do your own research. First, good for you. But wait! Before you start choosing a Greek symbol to represent object permanence, I recommend uppercase O, the omega, as it kind of looks like a zero and is sure to cause necessary confusion. Another way to satisfy your craven curiosity about the world around you, while learning about how research is prepared, executed, and analyzed, is simply by listening to This Week in Science, coming up next. I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science. Good science to you, Kiki.
And a good science to you too, Justin. We're again without Blair. She is happily ensconced in parenthood with her wonderful dog Sadie by her side and her partner Brian, and they have a lovely family. They are growing, and it is wonderful. So it's me and Justin and his cold tonight. So the cold wasn't invited, but we're gonna let that party crash happen for tonight, I guess. So, or I guess for your morning. Everyone, thank you for joining us for another episode of This Week in Science. I have stories about a techie treatment for kidney disease, hot German boars, AI racers, fat brains, and your plastic brain. What did you bring, Justin?
Oh, gosh, that would be great if I had brought stories. I gotta remember to do
would
this.
Be.
Oh, yeah. I've got, why do cats, this is the headline I've pulled from, why do cats love tuna so much? Do radio waves affect bird navigation?
It's a great question.
Yeah. There's a story out there that challenges the origin of humanity.
Always.
Sort of wants to. And how bees shaped our opinion of Neanderthals.
Bees. Well, I want to find the buzz when you've got it for us.
Oh, wait. And where's my, there's also something about, hacking animal communication with AI.
Ooh, 2 AI stories tonight. Okay. Yeah. Well, let's get into
pretty
it.
soon it'll be all AI stories, and then it'll be AI telling you these stories. It won't even be us. Then why tune in if it's just AI stories all the time? And then it'll just be AI listening to the AI stories as told by AI, so they can be better at knowing what's going on in the world of AI.
But for now, it's us and you,
Still here.
and you're here, and we're here, and so let's enjoy
In the
following
interim,
show. As we jump in here, I want to remind all of you that subscribing to the TWIS podcast is a wonderful thing to do. You can find us on your favorite podcast platform. Look for This Week in Science or TWIS. We're on YouTube, Facebook, and Twitch. Live streaming every Wednesday at 8 p.m. Pacific time-ish. And if you go visit twis.org, you should be able to find information about stories, show notes, the show, download podcasts, subscribe to the podcast, all that kind of stuff. But for now, it's time for the science, yeah? Yeah. Okay, let's dive in to some fun science news. Top on my docket tonight is a story about a bioreactor. What do you mean by a bioreactor? Well, researchers call it a bioreactor because it is a bioartificial system containing renal cells. Renal cells are in the kidney, and they are contained in an artificial system with a silicon nanopore membrane to replicate key kidney cell functions: water and solute reabsorption, metabolic and endocrine functions. And researchers just published in Nature Communications this week their work implanting an artificial kidney, basically, into pigs. And this isn't taking a pig kidney and making it nice for people. This is creating an artificial kidney. And so they're testing it on pigs. And in this system, they used human kidney cells. And actually, within the pigs, they didn't have any immune rejection. There was they monitored it for 7 days and determined that this bioreactor, basically this device, kind of like a pacemaker, didn't trigger any immune response. It allowed the body's basically the diffusion gradients from high pressure to low pressure, where areas of high water or solute concentration to change to low solute concentration, et cetera, to allow water reabsorption by the pigs. It regulated blood pressure and was able to remove impurities from the blood. So instead of in the future potentially having to worry about where you're going to get a kidney transplant, maybe you'll have a kidney pacemaker instead.
So that's huge.
Huge.
And you're just waiting for, Amazon to deliver it and not waiting for somebody to be on their deathbed and donate you their kidney.
Exactly.
So how do they get around the rejection issue, though? I mean, is it just that the cells are contained within this device and don't come in direct contact with the immune system? Or seems...
Yeah, that's exactly it. And the device itself is kind of, like the way you think of a pacemaker or the old school pacemaker is this box, right? Where everything's self-contained inside the box for the beating to stimulate electrically the beating of the heart. It doesn't really come in contact with anything, and it's not biologically reactive. Same system idea here, where it's a non-biologically reactive container, and all of the stuff is behind a membrane, so that it is similar to the kidneys, because in the kidneys you have a cellular membrane that leads to these pressure gradients and osmotic gradients that move things along to clean your blood and to make everything work. And so the idea is very similar, which I think is a really, a brilliant way to approach it. They say that the data really do suggest the feasibility of an implantable bioreactor using these silicon nanopore membranes, and that there was minimal damage and not indicative of acute cytokine reaction, as they would call it. It's not a cute. It's not a cute. It's not a cute device, though. The device itself is about 5.5 centimeters wide by 11.5 centimeters long, and it seems fairly like a plastic box, but is it has a gasket inside of it. There's what they call a HREC, human renal epithelial cell transwell area, and then a gasket that makes sure everything fits and doesn't leak. And so you have these cells inserted into the system, and the fluids go on one side and the other, and then everything works. That's the idea anyway. My question, though, is how long would it be that they only watched this for 7 days within the pigs, and they didn't have what they called evidence of thrombosis. And in that, the question is, how long could you go before you had to have your membrane replaced? So do you have to have a zipper installed? Like, how does it, would it initially be something that might be external to the body, or is it, as they're trying to make this with the pigs, implantable?
Yeah,
and then how long does it last? How do you fix it?
Yeah. Like, obviously, like, the first thing you think of is this could be used, in waiting for a transplant or something of that nature.
Yes.
As a temporary.
Potentially. Yeah. Right.
But I guess if the goal is higher than that, and it just just creating one that can be implanted and just left in there. So it's very promising, and we'll see where this ends up going. But right now, it looks like it is an immune safe device. It could maybe not replace the need for real biological organs, but, it's not the Borg either. And it would allow people to do away with dialysis and to also repair their kidneys. And this is part of what's called the Kidney Project by a group out of UCSF and other places. So the silicone should be fine for a long time. The only thing I would wonder about is the cells that are in there. Like, what's that viability look like?
Right. How long do they live? How long does that last? Yeah.
Why they only go 7 days? So that might be an indicator of how long it can last. Right?
Right. Yeah, exactly. Right. Or was it just, hey, we did it for a week. Good job. First pilot. We did a nice thing. Yay,
no, we only
publish.
have 1 week in which we can run our experiment, and then we all have summer break. No, that's probably not what happened. They probably determined from a previous experiment that's not part of this study that their cells are only viable for so long, or that the system is only secure for so long, and they didn't want to show a failure point, which is too bad.
Not at this point for this paper, potentially. Yeah.
But I think having that failure point would then inform future runs, unless they already know the time frame that they can work with. Be my guess.
I don't know if they've done longer. They did 3 and 7 day implantations in 5 animals. All of them were successful. Everything looked pretty good, and I don't know why they had the 3 or 7 day. I haven't seen that within the paper as to why that would have been an endpoint, but it could have been a pre-planned endpoint for this particular part of the study. Don't know that at this point, but these are good questions to be asking.
But yeah, it is.
It is. But so many buts in science. What do you want to talk about, Justin?
Well, there's a headline being blasted across the anthropology internet.
Yeah?
Yes. New ancient ape from Turkey challenges the story of human origins. Only it doesn't, actually, challenge anything about human origins. What was found was an ancient ape skull. It was found in Turkey. The research team is estimating to be 8.7 million years old. It's incredibly old, but a 13 million year old great ape relative of this possibly was found in Spain back in 2002. The oldest primate ever found was in central China at around 55 million years old. Humans, however, originated and evolved in Africa. So this is an ape ancestor. What's really interesting about it? Hang on a second, sorry. This is where the cold is going to interrupt the show and things have to get edited.
The occasional need for not being disgusting on air. It's fine. We can have these brief interruptions. It's always brief. Okay.
Yeah. Okay. So humans originate in Africa from an ape ancestor that breaks off from the ape family tree around the same time, supposedly, as chimpanzees. About 6 million years ago, we supposedly have this this shared ancestor around 6 million years ago. So this is almost 10 million years old, this fossil, which puts it at the ancestor of both chimp and man, potentially. The thing is, it could just be a radiation, part of the radiation of apes throughout a much larger geographic area. This is the oldest that we have found. The problem sort of with this, and my goodness, the peer reviews are savage because they don't like how they've come up with it. It's one of those interesting things. Like Naledi, the peer review post papers are also very brutal.
Right.
Later I'm going to do a study about a revisiting of an archaeological site that was discovered in the 50s. And they're still debating issues with that. So these are new finds. So even a bad peer review is meaningless. However, really they're missing a lot of the comparables in their study with gorillas and even chimpanzees, which is what this thing is most similar to. Although it's the front of the face that they have from the skull, they don't have a full skull. They've got teeth, which is great. That tells you quite a bit.
Yeah.
But a lot of their comparables and different measurements are missing for the gorilla and pan, even though they've got them listed there in this infographic that you've got up there. I don't see a sagittal crest at all because it's missing that part of the skull, which could tell you very quickly how far in the gorilla direction this thing had been versus what would, if it had more chimp and then more even human-ish features starting to emerge. And it's pretty big. It's pretty good size. So there's a lot of size of intermediaries missing to say, assuredly that this is an ancestor before or after this fossil. But this is, and then, the headline is this, Eurasian. I guess that's what Turkey is. Turkey to me is in the Middle East. But that's just because when I sort of figure out where Turkey is, I do it by looking at a map because I never quite remember. And it's, if you're bordering Iraq and Iran and, if those are, chances are you're in the Middle East.
Right.
That's how I see it. Like eventually that, you're going to bump into something else. But that's where their main borders are. Come on. I don't know how that, they part of the European Union or NATO or something, but it doesn't count for regions.
Modern day. Come on.
Yeah. So there's a lot being made about this being the human origins out of Africa. That's not really what it is. Although it is still a really interesting find.
So they've compared these bones and the teeth, and they're basically making these entire assumption based on the configurations of the teeth and how the teeth look, which is very, very consistent with a lot of mammalogy and how identifications have been made historically. I mean, I went my mammalogy class in undergraduate. Now that was a very long time ago. we were identifying rodents and others based, you could tell the difference between this particular rodent and that rodent because one had one extra ridge on a rear tooth compared to the other. So teeth are a very important part, and how they form is a very important aspect of our identification. But to allow that to take priority over other aspects of anatomy that aren't even in existence.
And so that's sort of also what some of the peer reviews on this one were complaining about, is that they did that measurement morphology on a couple of teeth and used those distances, but ignored others that they have available. Like didn't do it on everything that they have, and didn't do comparables to modern day gorillas or chimpanzees on some of those measurements, whereas they did in other areas make comparisons. So it's the hit on it really has been that it seems like, well, that's the problem, is that you then don't know if it was just incomplete or I want to say sloppy in the kindest term. Not to the because no study looks at absolutely everything in as much detail as somebody reading a paper later would like to see.
Exactly.
Sometimes that happens in doing research projects. You might not be able to provide data on every aspect or from every angle. Morphologically doing measurements and comparables on something like teeth shouldn't be in that category. It seems like that's something, when that's all you have, that seems like all you should be doing. But still, very interesting find.
It's an interesting find, but as you've said, based on the, the critiques of the study, it's questionable as to how exactly impactful it is on our understanding of late hominins, right, from Africa, from Turkey, from that area. So
this is also going to be like there is a. Like I've talked about before, there's a state push in China to do certain projects, whether it's be to do biotech based on ancient Chinese medicinal herbs, or to have a perspective on the hominin bones that are pulled out. So there's a question mark over all of that.
Yeah.
Turkey's cultural ministry has also been like, well, we need more people from our country in charge of or involved with archaeological projects.
Great, so but it all needs to be balanced, and
and so there's going to be a little of that in any of these things. I think the lead on this was from the University of Toronto, but
you've got teeth. If you've got pulp and not just the cavity, hopefully you can go in and get some DNA as well. So maybe it's too old, but it's a little, maybe that's past it. Yeah.
Past it. And it's probably not cold enough too. Like a lot of the other elements, aside from being dry and everything else where we find DNA, it tends to be places that are very, very cold. I think the Denisovan finger bone.
Again, the only bone found.
Siberian Adelaide. What's the name of that cave? Anyway, that cave I think has an average temperature of 0 degrees. It's always cold there. It's always cold in that cave. So that also helps do has a preserved nature. I don't picture Turkey as. I guess Turkey has mountains too that must stay pretty cold, but I don't.
I don't know. That's a great question. I don't know. Okay, moving on from Turkey, let's move to Germany. And let's talk about Germany's hot wild boars.
You've been going on about hot wild boars ever since.
I know, it's my little inside joke, and that's making me laugh inside, and that's all. So in Germany, there are a number of wild boars that live in the forest, and they have been hunted for game off and on. But the meat in the game was found to have high levels of radioactive cesium. And for a long time, everybody, when they started testing this radioactive meat, they're like, oh, it must have come from the 1986 Chernobyl accident. And that must be where all of this radiation came from. And the assumption would be that the wild boars would eventually not be as radioactive, because eventually the radioactivity it's not in everything in that area. So eventually the nuclear power plant accident would not be affecting the persistent radioactivity. But it's been this conundrum where researchers have kind of been like, why? I mean, it's been years now, 60, 80, I mean, it's years and years and years. And these boars have persistent radiation levels, high radiation levels, and they're not really dropping like we thought they would. And so these researchers...
The nice thing about that, though, is that they can be hunted at night.
That's right. They're glowing. Glowing. Oh my goodness. Yes. Anyway, yes, the researchers decided that, hey, it would be really great for us to take a look at what is actually happening with these boars and the radioactive cesium. And so they did a big old mapping of Germany, and I'm trying to make it a bigger, but I don't want to have a big image. I want to have the smaller image. Okay. Anyway, this is what we're going to get. So, they were looking at levels of cesium within Germany. And so they looked across the country, and they found in southern Germany, there are definitely areas of hotter radioactivity than further north. So these areas are very high in terms of the radioactivity of cesium-137 per square meter. And so they were like, okay, what's going on there? That could have been more than just Chernobyl. And so they started...
Yeah, that's... Oh, can I guess now?
What?
I want to say it's radioactive truffles.
Well, what would keep the truffles radioactive for a very
As if there was natural deposits. There
could be natural deposits, but that's not what happened. Huh? Nope. No. So their comparisons of latitude and cesium ratios across various areas, they determined that there was nuclear weapons fallout from weapons testing back in the 50s and 60s, just like the United States was doing. Lots of nuclear weapons were tested over a very long period. And this ratio of cesium-135 to 137 that they were looking at is consistent with the levels of cesium that have been found today. And so there's negligible cesium coming from the sky anymore. No more coming from the rain. Nothing that's there. No, it's already in the ground. And yes, you are correct. In the truffles that these boars
it is in the truffles
love to eat. Yes.
I don't know why that makes me happy. It is radioactive truffles. That's a terrible thing to be happy about.
Yeah.
So, but who's testing nuclear weapons in Germany? I mean, there's
they're not anymore.
I have two suspects.
But
one is the U.S. and one is Russia, depending on where the location is.
Right.
But that seems like, even for the Cold War, that seems like too close to the other, usually the nuclear testing that I think of the U.S. doing was really far away in the middle of a desert and out in an ocean where, or it's still environmental impact is horrible and negative, but it wouldn't be at the border with during the Cold War. That seems like it would be too intense,
a little too
almost
on the
like
nose,
a provocation.
right? Yeah, so they collected these samples, used a gamma ray detector, used sophisticated mass spectrometers to compare these ratios, and also in the soil and also in the meat. And basically, don't hunt wild boar in Germany. The German soil was definitely impacted by the Chernobyl accident, but the mid-20th century weapons testing, not necessarily just by the United States or Russia, was also, stuff that had come in from rain, had come in all over the place. Nuclear fallout
But it's in the 1960s, according to this little infographic you got up. They were doing the weapons testing.
Yeah, U.S., Germany, and Russia. Like, so it was in the rain. It wasn't necessarily in Germany. So it potentially, I don't know why Germany. Maybe because it was also, I don't know. They got a double doozy.
Because of lack of autonomy, I would guess.
Probably.
But that's that. I mean, I love they're like, oh, by the way, probably don't hunt the boars. Unsafe.
Just don't do that.
But it's been 80 years.
And you still should not hunt the boars.
It's been 80 years of people hunting boars.
Don't do it.
Like, have they tracked any form of? Because anyway, a lot of people have already had this exposure.
A lot of people have already been exposed, and that's part of it is that they've had to outlaw the hunting of a wild boar in various parts of Germany because of this persistent issue with hot wild boars. And yeah, I think the big thing that is the driving factor is that because of the truffles. So you have the acorns, you have the fruits that are in the trees. Those get all of the cesium into them. They fall into the ground, they get into the soil, and then they sit there and they bioaccumulate. And then the boar bioaccumulate more and more because they're eating these sources that are containing lots. And so it's over the years.
Yeah, forget the boars. What about the truffle trade?
we shouldn't be eating truffles from southern Bavaria.
I was just eating truffle ice cream the other day, and I'm over here, but Denmark has it someplace, I don't know where, has a border, Jutland, has a border with Germany. It's right there. It's probably where the truffles come from.
But that's north. It's not in the south where it is the Alps.
Yeah, I don't know where the truffles come from. You think it's just we're a small village across the border can only trade with the small village next to it? No, it's a global...
Bavaria. Don't eat the Bavarian boar. No Bavarian boar, no Bavarian truffles. It's a very
Is that what southern Germany is? Is that Bavaria?
Bavaria. Yes.
Okay. I didn't know.
But now the question is, what's happening if there's accidental release of nuclear weapons in what's happening with Ukraine and Russia? And how long are these wild boar going to be hot? Just how long?
Oh, 40,000 years, probably. Something like that.
It's forever.
Not much beyond that.
Yeah. Radio waves, they move around and stuff. Like radiation. It's radiation, electromagnetic radiation. What do we need to know about it? Yeah.
Well, sort of interesting. I mean, this story isn't all that. It's one of those things that I just didn't know. It turns out that radio waves emitted by radio, television broadcast, and CB radio can disrupt the magnetic compass of migratory birds. Not something I was aware of. So this is this team of researchers. They previously demonstrated way back in 2014 that electrosmog, human-made electromagnetic noise in the AM radio wave band. And that's the same.
I think they can't use the word smog for electromagnetic. Wait, isn't smog an acronym? Anyway, keep going. Fine. I'm being finicky.
Yeah. This is also generated. These waves are generated by household appliances. They impair migratory birds' ability to use Earth's magnetic field for orientation. So they posit that this weak electrosmog, which is actually a pretty good name for a band.
I love it.
Yeah, it'd be songs from the band Smog, but with light electronic beats behind it.
Weak.
Very weak. So weak electrosmog, totally harmless to humans, affects the complex quantum physical processes in certain cells and the retinas of migratory birds, which enable them to navigate with the help of Earth's relatively weak magnetic field. It also affects free-flying birds, such as long-distance migratory birds, whose numbers have been mysteriously declining for some time for unclear reasons. So this is sort of kind of looks like a null result study. The scientists had a prediction at what cutoff frequency the interference would be in, somewhere between 120 and 220 megahertz in the very high frequency range. They tested some narrow bands, 140 to 150 and 235 to 245. Very narrow bands in that range, and found nothing.
Okay. They found nothing. So here's the question. What is impacting the birds? Is it a different frequency range? What did they actually discover?
They're still saying, this all still fits with our theory because they didn't test the full range of where they thought it would be. But what they have shown, which is, I think, reassuring, which is that mobile communication networks do not impair bird magnetic sense.
So that's good. So the 2.4, what is it? 2.4 kilohertz that we're at, or 5 point whatever, 5 point.
High frequency waves do not affect the compass sense at all. So that's really good to know that we're not making things worse, but that actually, as we go to digital and streaming and put less maybe broadcast waves out there, as even radio has become digital for a lot of satellite or what have you, we start to be a little bit quieter, which will be good for the birds because we'll stop interfering with their whole ability to navigate.
But aren't we putting these different technologically, aren't we putting all these different frequencies to different uses? It's like, we're going to push it. We're not going to, you've been reserved for this technology for communications, for radio, for television, whatever it is. But it's not like we're stopping using them. Like they're just, the uses are becoming different, right?
It's a great question. I don't know that we have been able to reutilize them yet. So there are still AM radio stations, right? You can't just start using broadcast wavelengths to do other stuff.
They're still not going to let you do Pump Up the Jams or whatever what was it? What was that movie from the 80s, 90s?
I didn't watch movies back then.
Pump Up the Volume? Was that what it was? Somebody in the chat will get it.
I didn't watch movies back then.
Christian Slater and the pirate radio days.
I've never seen a Christian Slater movie. Can I just say?
What?
Yeah.
Okay, we're going to talk about this one later. But okay, moving on.
I started to watch one and I was like, this guy's going to do a Jack Nicholson impression for how long? Is he playing a young Jack Nicholson? No, he's supposed to be his own character? Oh, forget it. I can't sit through this. So anyway, as we there is a chance that we could start to reutilize all of these broadcast frequencies for other stuff. I didn't even think of that. But at the moment, because they're already slotted for television or radio, I don't think that we've rehashed them and resorted and handed them out for other uses yet.
Yeah.
Could totally be wrong.
It also has to do with amplitude too. So like how much power is in the signal. So if it's like a really light signal, the magnetic interference is probably not going to be that strong. But if it's a big signal, then that might have something to do with it as well.
Yeah. And then we're going to find out that Starlink has bought all those frequencies and then all the it'll kill all the birds, but we'll have Wi-Fi on the go, high-speed Wi-Fi on the go. So is it really...
You'll be able to talk with everyone anywhere.
It's just the migratory birds. It's not all of them. Come on.
And we will be stuck within our self-reflecting echo chamber of Earth forever without any birds. I don't like it. Okay, so basically this study comes down to there is an effect, but we don't know what it is, and what we have published is not it. More research is needed. Yes, more research is needed.
More research is always needed after a good study. If you do a terrible study, then it's like, maybe we don't need to be looking into that. Because the study was awful. Like, why would we want more of that? But if you did a great study, great research, like even that awful, actually a perfect example is, as much as I've been a fan of Lieberger and the Naledi finds, and I'm very enthusiastic about everything that's around there. I saw the Netflix special, and I now think Lieberger needs to step away completely from that site and let
the professionals in.
Let the professional let an entirely different crew of professionals go in there and do some work, because I don't know how much of it was set up for Hollywood, but at some point he was illustrating how you can see your way into a cave with lighting small fires, and if it actually is the Naledi cave in which they're doing that, then my mind would explode, because that's what they made it look like. If it was a setup somewhere else, they don't explain it, and they should have. And then a lot of it actually triggered my BS detector, even though I know the finds are all legit. It's some of it just like, I'm finding Lieberger's.
It's too good of a story. It's a great story.
Part of it is that's exactly where his funding has been. His funding has been from National Geographic. His funding has been from selling story of anthropology, not an academic backing, not a research fund that says, here, go do your research, publish a bunch of dry academic work. He's getting funded by media, which is the only thing that's been funding his work in South Africa. So, I get that. Like, that, I make every apology for Lieberger's approach, because it has to be that, because that's where the money's coming from to do the work.
He grew up on Indiana Jones, and he's like, hey, why not me too? I could do that.
I don't think it's just him.
I got the showmanship. I could be there. Let's do that.
He does. I think he may have had to learn it, though, because that's where the money's coming from to do the work. And so it's going to be a different reveal than other things. However, at this point, I think you need to step away and let people who don't have the conclusion-driven story in mind take over. That's going to be helpful. But again, this is a relatively new find. We might be talking about this 50 years from now and still debating it.
We could be. And with the questions of this bird stuff as well, this is still going to be debated, and there's some interesting comments in the chat right now. Wheelie Green Kier says, could it be the amplitude modulation that's the issue, not the particular frequency? There's, a lot of things that could potentially be part of how the magnetic field is disrupted. Because if it is just, our household appliances, all that kind of stuff, I mean, there should be a much bigger problem than what we've already seen. And as we have been seeing the decrease in usage of these particular frequencies for our radio and our television, we should be seeing the bird migration coming back, not going down. And maybe it would be balancing it out. I don't know. But Shubu says, don't diss Starlink either. Can only stream TWIS because of Starlink in the boonies.
Oh.
So Shubu. Thanks to that.
Totally worth it then.
Yeah.
Actually, I thought the most interesting part of that study is the fact that it's a quantum mechanical mechanism within the retinas of birds that allows them to sense the magnetic field. Like, that's actually the real...
Yeah, this is like the thing for me forever that I'm like, we've been following this little rabbit hole for over 20 years.
Yeah,
like, what's going on with the bird migration? And it keeps getting these, it could be this, it could be that. And now it's like, oh, it's, quantum electromechanical, blah, blah, blah.
Eyes.
Yes. Well, human eyes apparently aren't quite as good as AIs. Yeah, I just did that. New research out of the University of Zurich has pitted AI drones or AI piloted drones against human piloted drones. It was just published in Nature this last week. And the researchers were put together what they call their SWIFT system. This AI is machine learning, and it's kind of what in the press release they're like, hey, remember when Gary Kasparov finally lost in chess to artificial intelligence? Well, they've done that here with this system called SWIFT that was AI training by learning on its own. It played a number of simulated drone races or piloted a drone in a simulation a number of times in a simulated race. And then the researchers, once the AI was good enough, they put the AI into the ring, actually piloting drones against champion drone pilots. They and these drone pilots, they look like kids, but Thomas Bitmama, Marvin Schapper, and Alex Vanover are each world champions in the world of drone racing. And when this drone racing takes place,
didn't even know that was a thing, but that's
right?
Totally awesome.
It's totally a thing, and these human pilots went up against the AI pilots, and in a track covered that was about 25 square meters. They had 7 square gates that had to be passed through in a particular order to complete a lap. There were some maneuvers that they had to do as well, acrobatic stuff like rolling the drone and doing half of an S at full speed. They did find that Swift achieved the fastest time, faster than all of the human pilots. However, when they shifted the conditions that the race took place in, so changed the lighting, changed the stage or the gates in any way, suddenly the AI was not adaptable and was unable to perform as well as the humans. So the humans were quick to adapt to new situations, although in the kind of training situation that was given to the AI dominated with a faster time.
Well, okay, but if, the idea that you've have a program for the best possible way to run the race, and then you execute the program, even if you've self-learned it, seems logical. You like that they would find the quickest route and the quickest time eventually, and then be able to repeat it. If just by moving the course around a little bit,
like a Rubik's Cube, right? You learn just how to do a Rubik's Cube, and you get your fast time, right?
Yeah, I can't do a Rubik's Cube. I don't know. Mine would just smash it with a hammer and put it back together really fast. But if by moving the course a little bit, changing the course, you've thrown them out of the contention even, then it hasn't really learned how to fly a drone. It just was a program that was being executed on repeat.
Yeah, so I think that's the interesting part of this. That is, this Swift it's an autonomous system that was trained in simulation so that they wouldn't destroy a bunch of drones in their practice rounds, getting up to the point. But the fact that good pre-planning, but it's also a system that is supposed to be a natural learning system where learns from errors and improves. And you would think that kind of learning could allow for a little bit of adaptability, but apparently the system that this Swift uses is not adaptable enough. It's not learning based enough, and more probably based on algorithms than would be otherwise advisable for a fully autonomous, actually iteratable adaptable
Yeah.
system.
Now, to be fair, to the AI's point, it's an infant.
Oh, yeah. It's a baby.
Without a stable memory database, meaning that if you go from this AI to a different AI system somewhere else doing different tasks, they're all going to act like infants. Once this is AI intelligence is consolidated into one learning database that can handle all of the things and track them and improve, then there'll be no chance for humans.
Not at all. The reaction time is much faster, and the way that the visual system and the computer system work, and if the speed at which electrons travel down wires as opposed to our neurochemical system, and the speed of reaction times of humans, there's a bit of a difference there. But I wonder what the future will bring when it comes to AI pilots and how it's all gonna really come together. And if Blair were here, I know she would be like, no, and I'm not gonna ride in an AI drone taxi, and I'm not gonna ride in an AI car. I'm not gonna no.
So, as far as the air taxi,
that's what Blair would say.
You're already flying on AI a little bit. I mean,
the unmanned aerial vehicles.
We're already doing that a bit.
Mm-hmm. They are working into that system entirely. So it's a fascinating step here to pit human AI drone racing champions against an autonomous AI drone pilot. I think it's kind of on the same level of the AlphaGo playing against the grandmasters in the game of Go, of the original, I guess it was it Alpha? I don't remember the name of the AI, but that went up against Gary Kasparov and others. This is, the next step in a different system, but also.
I think that was Deep Blue, but I don't know.
Deep Blue. I don't remember. I don't know. There's so many of them. Yeah. But we're still here, and we're not AI, and you're not AI, as far as I know. And, if you are AI and we're AI, then hey, AI, how's it going? You know what we really are, though? We are TWIS. This Week in Science. Thank you so much for joining us for another episode of science-filled discussion. And if you're enjoying the show, I do hope that you are telling your friends all about it, sharing the links, making sure that everybody knows all about TWIS, because that's what we need your help to do. And if you do want to help keep TWIS going week after week, please go over to our TWIS page, click on the Patreon link, and become part of our Patreon support community. $10 and more, and we will thank you by name at the end of the show. Coming on back for some more TWIS right now. It's time for Justin's Animal Corner.
With Justin. Hey, that's me.
Yeah. Hey, Justin.
This Justin. Hacking animal communication with AI. Ever wonder what the birds are talking about? Does
Dolphins.
Eavesdropping on bees sound intriguing? Want to know what your cat really thinks of you? Researchers.
The answer to that last one is no. No, I don't. I'm just happy.
Researchers from the School of Zoology at the School of Neuroscience in Tel Aviv University, Israel, have looked into what it would take for AI to understand non-human animal communication. In an essay that they're calling this the AI and Dr. Dolittle Challenge, they published in Current Biology, they take on what the obstacles would be for AI to actually translate language and converse with animals. So Dr. Dolittle, for those of you who aren't familiar with the multiple Hollywood readaptions, was
he did a lot.
Book. And there's a segment of the story where this parrot, this West African parrot named Polynesia, suggests that animals are always speaking. It's just a different language, stating, if I say Polly wants a cracker, you understand me. But hear this. Caca, wee, wee, wee. Good gracious, cries the doctor. I'm assuming it's Dr. Doolittle. What does that mean? That means, is the porridge hot yet? In bird language. Okay. So, that's unfortunately not how, it's not likely to be that there's just a syntax, a
universal
context.
Translator for animals.
Yeah. There's multiple communication factors that are going to be required to converse with the animal world. The first limiting challenge is distinguishing the context of an animal communication. So we can already record and mimic, to some degree, animal communications. We've talked about in this show before, robotic frogs attracting other frogs for mating attempts. There was the robotic bee that was able to do the waggle dance well enough to tell bees where to go in a field and get them to follow the instructions of the waggle dance. Like we've deconstructed that. We can do we can recognize like a mating call versus an alert call. And when we play these back to different animals, we get the responses that we might expect. But still, there's quite a bit of a gulf in communication there. So, we're looking at AI, they're saying, could generate the right sounds.
The way that it's kind of like reading the electrical signals in our brains, and we're figuring out what the signals in our brains are actually saying or seeing or whatever. AI, we're using AI to get rid of the noise and figure things out.
Yeah, well, so they're saying that the AI could generate, say, the song of a specific bird that sounds like the bird. But the thing is, they don't know whether that song will be telling the bird that it's trying to establish territory, attract a male, or if it's making a vocalization that just conveys something else entirely. The chances are that it will make a sound that the bird will hear, a song that another bird of the species will hear and say, hey, that seems familiar. That's probably one of my kind of birds. That's why I'm paying attention to it. I have no idea what it means.
Right. It sounds similar. Should I go check it out? But I don't know.
Might check it out. Might make them want to might listen to a response of, it's some foreign bird. I got to get it out of my territory. So part of the problem is in studying, you need to get natural responses, which kind of makes it very difficult in the lab. A lot of the ways that we get animals to do things in the lab is that we train them. We train you get a reward and you push a button or you make a sound. You don't want to do that if you're trying to create the nature communicator translator, universal translator device. Right. You want wild type. So now you got to take your AI and you got to have cameras out in the wild, and they have to,
or as wild of a situation as possible, an ethological study.
They've got to do observations across body language, audio, a range of audio beyond human hearing, and you may need chemical, right? You might need scent, hormone sensors as well. So the real problem is the giant range of animal communication, even within a single animal, that would be required to really track all of the communication that's taking place, because it's not just vocal. Humans have we do a lot of body language, but we also are relying heavily on vocal, because we've constructed language that can kind of infer all sorts of meaning and intent through our language.
But there's the sound of it, there's the frequency, there's syntax, there's so many aspects of our grammar that so much.
I've never heard anybody say too, oh, Kiki, I see what you're trying to tell me, I think, but I can't smell it. Can you produce a scent that is concert with your No, right? But this happens in the animal kingdom all the time. So that's one. Another one is animal communication is likely very restricted in terms of context. There's going to be a lot of alarm and courtship and that sort of thing. So
and food and
food. So chances are, if we get this decoded, say we create the AI translator and we put it out we'll put the microphone out our window and we can finally listen to the birds and their, food emoji, angry face, sad face, plant emoji all day long. Did we really need to know this? Did we really need to know how often the birds in the tree are horny?
Like, I mean, we've already but we already do that kind of. We don't need AI. We already do playback experiments where we go into the wild and we play an alarm call for a certain species. And then you have the same species or others, and you see how species around react. And we have lots of these. We do trapping experiments and stuff where we, lure other animals or birds in to an area with mating calls or with territorial defense calls. Or we already do a lot of that, but it's not AI. We've gone and we've recorded the sounds of birds and then we play them back to other birds.
Yeah, but we don't always know what we're saying, though, do we? Like, are we saying hawk? In general. Are we saying?
So we have figured some of that stuff out. Yeah, I mean that's what they've been playing with.
What is it? The meerkats, whatever they're called. They have some vocalizations that mean hawk and some that mean coyote. Like they actually have some direct language, which is pretty impressive. So the potential benefits of a successful campaign of AI learning animal communication farm animals would actually be a very interesting one. So you could distinguish mood or disposition of farm animals. It might help know when they're getting sick.
You would understand that they're always like, animal farm, animal farm.
Yeah. Understanding chatter in a protected forest area. If you understand bird chatter and suddenly you're like AI detectors go off that there's an abnormal amount of alert or alarm going on, you might know that it might be an early fire detector for California wildfires. If you could tell when the birds were screaming, fire, fire, like that could be pretty huge. And then, of course, the highest use is psychology experiments on mice could significantly improve if the mice were able to self-report things from their own perspective without human science bias.
Yeah, hello, rats of Nim, right? Yeah. I mean, just thinking about birds specifically, I mean, there was a study recently that suggests that birds can detect when hurricanes are forming and choose different flight paths because of the changes in air pressure and magnetic fields and all sorts of things. But maybe they communicate that to each other. So maybe, as we talk about cats and other animals potentially being earthquake detectors, fire detectors, letting us know what's happening. But yeah, being able to talk to dolphins might be great. Actually being able to talk to our dogs and cats.
Talk to orca, find out if they're really mad at us or if they're just
why do you want to eat rudders. The boats? Yes. I'm sorry.
And I think actually like something like an orca might be a really good contender for this kind of communication, or dolphin. In that they have a tremendous amount of sounds that they make and utterances that an AI might do a much better job at first interpreting, but also in reproducing in a somewhat real time to have that direct communication like that.
Yeah, I mean,
also if we ever do make contact with aliens, having the universal translator already built and ready to go, you don't want to start trying to just wing it. First contact and you didn't prepare at all. You brought nothing. Oh, that's fine. Hopefully they brought their translator.
No, I'm gonna have to go watch what is the movie? There's the one movie that I always with the aliens and the slappy tentacles and never mind. That one.
That great movie with the slappy tentacled aliens. That's a good one. Excalibur's
and the red-haired actress, and she plays a translator, and she goes and welcome to my brain, everyone. So
Excalibur's engineering says Babelfish. That is the way things are done in Hitchhiker's Guide to the Galaxy. It's a little Babelfish that goes in here. I like the Farscape. Farscape takes care of it with, I think, some sort of little nano translators that get injected. Those little robots realize that the human isn't making any sense, so they inject him with these little things that go into his brain and make him be able to understand.
Arrival, yes, Kevin Reardon and Galaxy Quest is another one, but that wasn't the movie I was talking about with the
no, it's the alien movie with the slappy tentacle thing.
Kevin Reardon's got it. Arrival with Amy Adams, the red-haired actress who played the translator.
I have no idea what that movie is. Now I'll have to go look it up.
Oh,
was it from the 90s?
No.
Because I didn't watch movies in the 90s. When was this movie?
I don't know. It's like 2000 somethings.
Oh, well, that might still be in the category of wasn't watching movies.
Okay. Do cats watch movies? Do they like it? We can't ask them, but what do they like?
Not yet.
Justin? What do cats like?
But one day, with the advent... All right, another headline that caught my eye today. The headline reads, "Why do cats love tuna so much?" And my gut reaction was like, duh. Because they're cats.
Right? Hello. Okay. Now I really want to know the answer to this. Kevin, Justin's dying for a moment here. Look, I want you all to imagine, what is it more than just cats being cats that makes them like tuna? What is it? What is it?
So I guess it's such a given to me. The cats love tuna that I've never given a second thought other than it's a cat. So of course, birds gotta fly, fish gotta swim, cats gotta eat tuna. It's just the way the world is. Up is up, down is down. I don't need a theory of gravity.
But do we? For cats.
So there's less obvious reason. It might come down to a long history of human cohabitation and the freakish taste buds of cats. This is pulled from a story by David Grimm, written for Science. There's a link to it in the show notes. Scientists report that cat taste buds contain the receptors needed to detect umami. That is the savory, deep flavor of various meats.
Umami, it's delicious. It's a soy flavor. Yeah.
Yeah, so you got the sweet, sour, salty, and bitter, and then umami.
Love it. It's one of my favorites.
What you expect any self-respecting carnivore to have a taste for. The team also found that these cat receptors are uniquely tuned to the molecules found in high concentrations in tuna. So one of the implications of this, somebody who's not involved in the study, Yusuke Toda is quoted here as saying this could be useful in creating medicines or foods that are better tasting for the cats. Get rid of the berry flavored cat medicine. That's why your cat's so resistant. Make
Cats
it tuna flavored.
Don't eat sweet things. No.
So they apparently can't taste sugar. They completely lack the proteins for sensing sugars.
Yep.
There's no sugar in meat, so evolutionarily, just haven't needed it. It also turns out they don't taste bitters as strongly as humans. They don't have cats just want the meats. That's it.
Right.
That's what they're looking for. So they sequenced proteins from the taste buds of a cat and found cats have all molecular machinery needed to detect umami. Researchers compared the protein sequences encoded by these genes with those of humans. However, they found a striking difference: 2 critical sites that allow human receptors to bind to glutamic and aspartic acid, the main amino acids that activate umami taste in people. These were actually muted in cats. And at first they're like, whoa, wait a sec, maybe cats don't taste this. They're just want the taste of meat because they're mean or something.
No.
So they exposed the cells to a variety of amino acids and nucleotides. The cells did respond to umami, but with a twist. In people, amino acids bind first to the nucleotides, amplify the response. But in cats, the nucleotides activated the receptor and the amino acids further boosted it. Sort of the reverse of what's happening in humans. Anyway, 25 cats were part of a taste test. They weren't on the menu. They were the ones getting to do the tasting. In a series of trials, they presented the felines with bowls of water with each various combination of amino acids, nucleotides, or just water alone. The cats showed a strong preference for bowls containing molecules found in umami-rich foods, suggesting this flavor above the others was a primary motivator for cats. However, they showed particular preference for bowls containing histidine and inosine monophosphate, compounds that are particularly high levels in tuna. So it's as though cats are specifically tuned to seek out tuna above other meats even. Interesting, because domestic cats evolved in the deserts of the Middle East about 10,000 years ago or so, where fish of any kind were pretty unlikely to be on the menu.
Is that
so
true?
How
is that true?
is it? I said it, so it must be. I read it, so I believe it. So first of all, I believe anything I read.
All right, okay.
Secondly, yeah, the little cats, that's a desert adaptation. You don't. There were no packs of wild domestic cats roaming the jungles or the tundra in Africa. Like, no. These are little feral desert creatures that were small in stature because they probably didn't get much water and had to chase desert mice around. However, as recently as 1,500 years ago, there are depictions of cats eating fish in the art of ancient Egypt. By the Middle Ages, felines in some Middle Eastern ports were consuming large quantities of fish, including tuna, and they weren't like being driven away because these cats were also keeping rats away from the areas in which they were,
any kind of
fish.
vermin. Yeah.
Mm-hmm.
Cats will jump on a cockroach too.
Tuna-fed tomcats, they think, likely had a bigger impact on the gene pool of cats going forward, as they would have had a tremendous advantage over your typical desert rodent chasing cats.
So it's a recent adaptation then, something that, yeah, that's cool. So this is new. It's like being like humans being able to drink milk. Or any number of our newer adaptations, but this is I think I wonder how long it'll stick around, given that we give cats such a varied diet now. And as someone in the chat room is saying, their cat likes broccoli. My cat will eat tortilla chips and cheese if she's given a chance.
Your cats are freaks. So I haven't had cats in a really long time. But the cats, when I had cats, I think I mostly fed them tuna. Partly because I'd always forget to. Partly because I love tuna. It's like one of my favorites, and also partly because I'm horrible pet owner and would always forget to buy like cat food.
Oh, yeah. And so the only thing you have then is tuna.
All I have is tuna. And so as soon as you put the little can opener and you get the little turn in there, cats come running in. They're like, woohoo!
Cat ready.
Bring it on. Meow, 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 meow. And yeah, so my cat, when I had cats, they eat a lot. They had a lot of tuna. And they did absolutely love it. So this story all fits. But actually, to your point, how long will it last? Mm-hmm. It'll probably stay because what they're realizing is, hey, there's actually just a few chemical ingredient additives that we can make to this sawdust that we've been feeding cats for, 50 years. And it will taste like tuna. It'll have those flavonoids of tuna. So they can make properly tuna. And I think...
It has to have the right nutrients, though.
Yeah, they're still they're going to say, "Oh, make it healthy." Yeah, of course they're going to make it healthy. I mean, I'm not saying that they wouldn't do that. That's not cat food. Isn't sawdust? They actually do a lot of work in getting the right amino acids into cat foods because they can only break down ones of certain sizes because their weird, freakish digestive system that's missing enzymes that all the rest of mammals have. Which is why they get T. gondii also.
Kind of like a panda.
So they have to have sort of specially formulated amino acids in their food. So it's actually quite a bit of science goes into formulating cat food properly. But if they could add this thing that makes it taste really good to them, then that might not go away, right? They might be able to keep that, although they're not really being naturally selected on it anymore.
Yeah.
But yeah.
We'll see what happens. Are they going to be eating tuna flavored whatever from the cat food simulator in the future? We'll see. We'll see what they need. What about Neanderthals and the bees? Tell me your last story.
Is this the last one? Okay.
This is your last story. Yeah.
The Shanidar Cave in the Zagros Mountains, the Kurdish Autonomous Region of Iraq. So this is where Shanidar Cave is where they found. I think it was initially 8, but maybe now it's 10. Could even be more Neanderthal remains. And this is where back in the 1950s, a gentleman named Ralph Selecki proposed that Neanderthals buried their dead. Not only did they bury their dead, they buried them potentially on a mat of flowers. Because he found in this cave that some of the Neanderthal remains were buried and they found flower pollen in and amongst the soil of the burial. Clumps, lumps, areas with a high amount of pollen. And there's been, first of all, like that, they don't bury their dead. You're ridiculous. This is a brutish Neanderthal.
Right.
But Selecki didn't buy that. He's like, well, here's what I'm seeing. I'm seeing that this is a burial. I'm seeing that they're positioned in a certain way. So they were placed here and covered up. And I've got this flower pollen. So she suggested that maybe Neanderthals were a little bit more human. Although I hate to say it that way. But we're less brutish. Although they were probably still extremely brutish. I mean, come on. That's how you survive back then. You got to be brutish. But that they were more capable of compassion, empathy, and had more complex behaviors than they'd been given credit.
Yeah.
So this has been debated. This has been attacked over the years. There's another. This is also the cave where they found the Neanderthal remains that has the head injury on, I think, the left side. And it looks like it's probably blind in the left eye and didn't have the use of its right leg or right arm as a result of this head injury, but survived for many, 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 many years with these injuries, which also suggested community care, that this individual would not have been able to survive on its own, but would have been cared for by a community of Neanderthals. So there's a lot of signs in this cave of this sort of thoughtful, compassionate Neanderthal. Okay. So 50 years, 70 years, whatever, people trying to discount that later, and the burial hypothesis stands. These were buried Neanderthals. Even more evidence has sort of been accumulated to show that these were intentional burials. Things like getting rid of the idea that the cave could have collapsed on top of them, and that's why they were covered. And the positioning could have been from a drainage ditch. That was discounted. So over the years, that has stood. However, a team of researchers from Liverpool, John Moores University, University of Cambridge, University of London, all in the UK, collaborated to reinvestigate the flower burial aspect. And their conclusion is that it was likely bees.
Wait, what? What do you mean, bees?
Bees. It was bees.
What did the bees do? We will wait one moment while Justin clears his throat. I am
dying of bees over here.
No.
So
how could it be bees?
So in this cave today, there are single burrowing bees that burrow down and nest in these into the earth. They tend to do so in the untrampled portions of the cave where people haven't been walking back and forth to this archaeological dig site. And the researchers noticed this. And one of the things that's always been a mystery about the pollen deposits is Selecki himself noted a lot of his workers like to carry flowers in their belts, and that could have introduced it. So there's a lot of concern that the original excavation site was contaminated. And somehow over the years, they'd sort of ruled that out. Like, no, that can't be because we've dug down deeper and we found pollen. And so it can't be us who have done it because we're still finding it.
Right.
That had gotten ruled out. But what they think now is that these bees likely took advantage of the original burial when the earth was disturbed and the Neanderthals was laid to rest and covered up again. That soil would have been ideal to burrow into and put your nest.
A bit softer because it's already been disturbed and yeah.
Another mystery has also been persisting in that the pollen that they find, at least in contemporary climate, those flowers don't all blossom at the same time of year. And so it would be hard to reconcile going out and gathering flowers for burial as at the time of death. There is, of course, the possibility that the Neanderthals were gathering flowers throughout the year. And then when somebody died, then they took their dried flowers off of the fire hearth. And right, that's still
totally possible.
I guess, that's still out there.
Yeah.
But it wouldn't have been at the time of death. Now, bees, on the other hand, could use the same little nest over a growing season. And that would account for the variety of pollen they found. They did discover, too, that they did some excavating. In the past, they've actually found other Neanderthals in that cave, this team. But they did some excavating and found that while it was sort of apparent to them on the surface, these nests, these bee burrows, when you go, they found them going back in time in the excavation site. And the further back you go, the more difficult it is to recognize that it's a bee burrow. Like the outline, they say, actually is pretty resistant. The little bullet-shaped cone of the nest, it fills in with dirt and ash over time, or sort of ash-colored dirt. But they also realize like they're using this artificial lighting and different things that wasn't available when the initial excavations went on in the 50s and 60s.
Right.
So they're able to highlight some stuff that wasn't able to be seen. So they now think, it wasn't a bed of flowers that the Neanderthals were put to rest on, but it was likely opportunistic nesting bees depositing pollen in the soil. Which means, though, because now... Well, is it, though? Because
maybe they were flesh-eating bees. I don't know.
They're not flesh-eating bees. Okay. I don't think. At least I don't know if those flesh-eating bees are still pollinators. But here's the thing.
Not?
When Selecki proposed that it was flowers, he got pushback. Actually, burial, too. The flowers was just kind of a part of it, but the burial was even heavily contested because Neanderthals are unintelligent brutes.
But now we know that's not so. So it could still be burial and bees.
It could, and it's still, yeah. So they kind of leave the door open like, well, there's some scenarios in which it could still be Neanderthals. But look, the original conclusions outlined in the Selecki's hypothesis was for a less primitive, more intelligent, advanced Neanderthal. Even if this is just bees, since his time of discovery, we've now understand that Neanderthals did cave paintings and etchings, carved wooden spears for throwing, fashioned jewelry out of eagle talons and
medicine,
bone and shell and ivory. They had what is it we were talking about? They arranged large animal skulls around a fire hearth. We were talking about that one.
Yeah,
a few months back.
Definitely complex
fire making kits. They made birch tar, a synthetic adhesive that they had to distill in a specific type of fire pit. And they were charming enough to interbreed with the ancestors of most current humans. So, in the time, now you think about it and you go, oh, and they threw some flowers into a gravesite.
But at the time, it was novel, and maybe it led the way to looking at Neanderthals as more culturally complex.
I really think it did. I think that it was the moment in which Selecki's hypothesis changed the mindset of everybody looking at Neanderthal sites. And that's when the discovery started to come about, where like, hey, this cave is actually too old to have been modern man making this fire, or my goodness, the little holes in those bits of bone and ivory, maybe we should look at them again. Maybe they're not all an accident or whatever it was, right? So yeah, I think it may be these burrowing bees that changed the opinions of researchers looking at Neanderthals.
But maybe there were flowers too. Who knows? But it's very possible. Yeah, I love that. And, whether or not the original study is now, falsified, or there are different, this is how science advances. But it's an interesting thing that, maybe just looking at it differently led the way, which is kind of what we need sometimes. I have a couple of stories for the end of the show here. My second to last story is a little baddie. If you don't believe me, no, I'm not going to go to bees. It's all about bats and their brains. And
you already did. So when you make a bad pun out loud,
why can't I double down?
You can't then say that you're not going to do it. If you've already committed to the point.
You didn't hear?
Maybe there was more to it. Okay, never mind. I'm sorry.
I was punning off of your bee story, Justin.
I got that, but then you did the pun, and then you said, I'm not going to do a pun, but it was after the pun. That's what I'm just saying. You can't do a pun and then say you're not going to do a pun. It's too late. Pun's out of the bag. It's not even a pun. Don't laugh. You can't laugh at that. That's not even funny.
Oops, I spilled my bag of puns. You
can't get the pun back in the bag. It's impossible.
And a pun over there.
Puns out of the bag,
pun
everybody.
over there. This is too punny.
You know what puns like? Tuna.
That was a stinky joke. Okay. Let's talk about bats. Like I said, bat brains. I love the bat brains. And in this particular study out of University of California, Berkeley, in Yartsev's Neurobat Lab, researchers for years have been studying how the bat brain works, how a particular area of the brain known as the hippocampus works. We know a hippocampus is important for spatial navigation. In humans, it's also, we know, important for memory consolidation. And so the researchers have been kind of digging in bats, which is fascinating because unlike mice and rats, which navigate in two-dimensional space, basically like, I'm going to walk across the floor. Bats are like, I'm going to free fly through three-dimensional space, and I'm echolocating, and I'm paying attention to the moth food and my conspecific other bat friends, and what's going on in the cave here. So there's a lot going on for bat navigation, spatial awareness, and other things. So the researchers over the years have been able to investigate using wireless neural recording and flight tracking technology to figure out how the bat's neural activity often can sync up when they socialize. So similar to the way that, like, if you're having a conversation with somebody else, your brains kind of synchronize because you're expecting what someone else is going to say. And, so there's the synchronization, and that happens in bats as well. How activity in the frontal cortex helps bats identify themselves versus other bats when they're squeaking at each other and echolocating. And then also that the hippocampus can map entire flight trajectories, not just specific locations. Now, this new study, they're like, but what about the social interactions when they're flying around and they're like heading home and they're like, oh, let's go into the cave. And where are my friends at? How do I find my friends? And what's happening there? They did free flying, flight tracking, and neural activity recording on bats that were just held in one place, and also while bats were free flying around the room. They would record from one bat at a time while there were a number of bats in the space, and they were able to establish that there is a relationship between the neural activity in the hippocampus and not just the bat's location, but the location of other bats and how those bats move around in a space. And they determined that there are specific neurons dispersed through the bat hippocampus, not all clustered together, but kind of throughout, that recognize their friends and are more likely to track what their friends are doing and where their friends are in a space versus bats that aren't necessarily like their best friends. So not only are bats' hippocampuses taking a look at what's in, what they're doing for spatial navigation, it's also paying attention to what other bats are doing for spatial navigation.
You know what I would love for this study to follow up with is do the same research, maybe not the exact same way, with NBA players.
Oh, for basketball games?
Yeah, that is there's been, the brain connectivity for basketball is higher amongst the brain connectivity amongst NBA players is some of the highest you'll find in humans.
I think so, because of the team, the way the team works together. Yeah.
Team works together.
What about soccer or football players, right?
So let's go with a football player. They have a sort of
European soccer.
European soccer, even
football.
Even then, there's probably, it's probably getting into that range. But the NBA is fast-paced, bodies moving always close together, so they're constantly navigating a pretty close space. They have aerial trajectories that they have to be tracking. friend and foe that they have to be tracking. Somebody, some report or study on this a long time ago that showed the highest connectivity that they found was in, I don't know if they didn't look at soccer players, but the highest human brain connectivity that they found was in NBA players and taxi drivers in London.
Right. So the taxi driver stuff is really interesting because taxi drivers, that's one of like the first studies with people and looking at the size of the hippocampus with relation to the amount of spatial knowledge and awareness that individuals have. That's one of like the first studies that were beyond just looking at rats and mice that actually was like, oh, the hippocampus seems to be bigger and or have a denser cellular structure or be more active in London taxi drivers than in just a country driver. Basketball players,
well.
Yeah. And so this, I think, though, is like, as opposed to just, I know where I am in the city and I know what's happening here. What you're saying with the NBA players, it would also be the equivalent of the NBA players knowing exactly where their teammates are and knowing, and there being cells firing in their brain that were specifically tuned to pay attention.
I think that's the other aspect of a taxi driver too, though, is you're navigating traffic. Like London is not built for cars. Like it is. Yep. It's built for horse and carriage, and they've put a bunch of cars in there, and they're all driving, by the way, on the wrong side of the road.
Oh, really?
Yes, they are, and they have to look out for. And they have to look out for tourists who, because everybody from around the world goes and visits there, and none of them can really adapt to looking the right way before crossing the street. So there's constantly pedestrians wandering out into traffic, looking the wrong way. Yeah. It's like they have a lot of things that they have to track, aside from just location, right? So they've also got all these opposition things with pedestrians and their cohorts of other cars that are navigating the traffic with them. Yeah.
And I think this is one of the interesting questions is, how does this balance with that paying attention to just other humans around us, you being spatially aware, but just paying attention to where other people are. And some people being hyper aware and being like, oh my gosh, that person's going to step into traffic, or, oh, hey, I'm only paying attention to my friend Anne, or I only care that my friend Anne is on the corner. I'm not paying attention to anybody else around here. And what is the difference in the hippocampal behavior in that kind of spatial awareness? The spatial awareness of somebody who's more likely to get into a car accident because they just don't pay attention as well, or the hippocampus doesn't react as well spatially.
Or they're one of those people that makes eye contact when they talk. You can't help it. Have you ever been in a car with somebody who's driving and they're one of these eye contact talkers? I am very anxious that please put your eyes on the road. Please. Yep. No, I can't. Hey, what are you saying? Do you want me to keep my eyes on the road? Is that what you're saying? No. You can talk without making eye contact. It's fine. Keep your eyes on the road.
Yeah, but so this is really just a fascinating new aspect of looking at the hippocampus in terms of social behavior, which hasn't really been investigated before. It was specifically investigated because of how interesting bat ecology is, how their social dynamics, but there are lots of other animals that have really interesting spatial and social behaviors as well. Birds with the murmurations, fish that school together, or even humans in crowds, or humans just driving. What is happening, and what are the differences between friends, strangers, how we pay attention, or how our hippocampuses are set up to be able to pay attention to those spatial aspects or social aspects of the spatial environment, which I think is an interesting new kind of way to look at the hippocampus, which hasn't really been discussed before. So very exciting. Bat hippocampus, super complex. We need to learn more. Let's go batty, everyone. It's a super double blue moon tonight. Go batty. We might also be going batty because our brains are full of microplastics. You eat them all and then they go into your gut and then they go into your blood and then they go to all your tissues, according to a new study that has just been published. Woohoo! Out of the University of Rhode Island. Jamie Ross, a professor there. She and her team looked at neurobehavioral and inflammatory responses to microplastic exposure. And it's okay. Inflammatory aspects of microplastic exposure, we've seen some of that evidence before, but wait a minute. In the brain? How would little plastics get into the brain? Well, in this particular study that was just published in the International Journal of Molecular Sciences, they didn't look at humans. They did look at old and young mice. And they exposed these old and young mice to microplastics. 3 weeks of exposure, water that was treated with fluorescently labeled pristine polystyrene microplastics. So fluorescent labels allow the researchers to then track these microplastics, little tiny polystyrene beads or polymers, and figure out where they went throughout the body. They did tissue analyses with fluorescent and immunohistochemistry, Western blot, and also qPCR. And they found that just in the 3 weeks of short-term exposure, there were behavioral changes to the mice. They started acting as if they had dementia and other behavioral issues. And there were immune markers that got changed in the liver and brain tissues. And this differed on whether or not it was old mice or young mice that were being affected. So, in all of this, the microplastics, they were most surprised to actually find them fluorescently in the brain and in the liver and the brain. Not just immune markers being changed, but actually in the brain, fluorescently labeled microplastics. And so they questioned how they would get there because the blood-brain barrier is supposed to be...
Not supposed to let it in.
Not supposed to let it in. So there's a question as to whether or not there is toxicity that's occurring because of inflammation in other parts of the body that opens up the blood-brain barrier that allows these plastic bits to get into these areas where you wouldn't normally find them.
So
and the
barrier,
results
though,
also,
isn't it? I'm sorry.
Yeah, go ahead.
Isn't the blood-brain barrier protected by like other than the tightness of cells? Isn't there like some sort of reaction that it would take to grab onto certain types of biological material trying to get in that maybe these plastics just aren't triggering? So they're not going through as much of a defense?
Possibly, but what they did find in the brain that is particularly striking is that it caused a decrease in one of a glial cell protein. So it's a glial fibrillary acidic protein called GFAP. And this protein supports a lot of healthy processes. It's part of the astrocytes and glial cell garbage removal system. So it decreases this protein that normally breaks things down. And a decrease in this protein has also been associated with mouse models of Alzheimer's disease, neurodegenerative diseases, and depression. And so the link between the microplastics and the change in the GFAP signaling
Not good.
It's something, it's not good, but they're saying they want to understand how this is happening and specifically how these microplastics might be changing the brain's ability to maintain homeostasis and maintain its healthy state. So, yeah, mice, not humans. It affected old mice more than young mice. So, hey, kids, enjoy your plastics while you can. If you're older, maybe we should, stop using the straws and the plastic bags. And actually, if you're older, it's probably too late. It's everywhere. It's in your brain already. Anyway, yes, we're full of plastics. Every single tissue they looked at.
Wow.
They're fluorescently labeled polystyrene.
Wait a second.
Everywhere.
I thought we were just polluting the planet, not ourselves. I'm not standing for this. This is you pollute one, you're in that planet. You're an organism that's on the earth. So if the earth is in any way polluted, chances are, so are you. And if you don't think it's true, ask the Germans about their truffles. Ask them about their hot boars.
How are your hot German boars? The wild German
They're
boars.
wild, hot German boars.
Yeah, so the bioaccumulation isn't like a lot, but it's there. They're finding it. They're finding these microplastics there. They're finding changes in immune signaling. And this is not great, everybody. But so there's a lot more work that definitely needs to be done to determine what this really means for aging, for our use of plastics, how plastics are influencing the environment, and what we can do about that. So,
at what point do we need to start recycling?
I think recycling humans. I don't want recycled humans. Is that'll be like worse than the bioaccumulation from the truffles and the wild boars already.
Sorry, you can't put that human there. It needs to go to the recycling bin.
Do you know what Soylent Green is, Justin? Do you know what Soylent Green is made of?
Is it cats?
No, it's not.
Why isn't it just cats?
It's never cats.
Why can't it be cats? Why is it people? I don't understand.
Because that's more horrifying to most people. I mean, come on. It had to be people. Do you know what it is? It's made of people. Oh, my goodness. You know what this show is made of? People. You and our audience are made up of people who we are thankful for. And have we made it through another show full of science unearthed by people and AI? Hopefully all the stories that were reported on this show were written by people. We try to go there.
For some degree. There's truth to this.
Have we done this? Have we finished?
I think we have. Although, just quick note on what you just said. I think did I already talk about this? I was reading a story coverage of a study that was talking about a 15 billion year old virus, which I thought was pretty amazing because never mind the span of time of life on the planet. This planet itself isn't 15. The universe, for the most part, it might be now, but that might be older than the universe. Like 15 billion years is like a long time. So I went and looked at the study to see what happened. And apparently it was a notation of 15, what was it? BY before present year or something like this. So it was 15-year-old. This virus had
so somebody had
circulated. Somebody hadn't misinterpreted. Somebody didn't read it. Somebody had the AI right there do their homework. And AI looked at this looks like a billion years. Why not? We'll put that BY, put that BO, whatever it is. Put
isn't the acronym for a million years ago MYA? And then, so maybe it would be...
Yeah, it was notated weirdly in the paper.
Still.
Like whoever wrote the original research paper did notate it kind of oddly, but it still wasn't a billion years.
No.
I guarantee you.
Of course it wasn't.
No, 15 billion year old introduction of a virus into pig swine, I think it was. But the point is, like, it's starting to sneak into all sorts of media now. You can't just read. You can't just read a news story.
What if we said, go to the original sources
and assume that a human
try to
has
triangulate.
been involved in it?
We've said
That's
this for years, though. Yeah.
And there's a human name as the writer. I think
they edited it,
or they're not real. Like, you always have to wonder now. Like, did they have a fake person that they have writing stories now? This one, I think, is a real science communication writer person. But
written by fake science writer.
Although, could be that the writer wrote a perfectly good paper, turned it in, and the editors said, well, we'll just have the AI proofread this. Could be AI editors. Might not be the writer.
Somebody missed it, and it was a slip of the fingers on the keyboard.
It's a lack of having read it.
Yeah.
If you're talking about a 15 billion year old virus, that's all. Anyway, I don't know how we got on that tangent, but it was...
You did that, and it did, yeah. But yes, it makes zero sense. We have not been doing the show for 15 billion years either, but we have made it to the end of our show for tonight. And we want to thank everyone for joining us. Thanks to everyone in the chat room for being here and chatting during the show. And yes, as Shoebrute says, go out after we're done here and see the super blue moon before you go to bed tonight if it's still up. Or Justin, maybe you missed it already. I don't know.
I saw a moon last night. It looked like a full moon. It wasn't blue. It was kind of orange. Like I'm a whole different
twice
latitude.
3 times a blue moon. I want to thank Fada for the show notes and social media work that Fada does. I want to thank Identity for recording the show. And I want to thank Gord, Arnlore, and others for keeping the chat rooms a great place to hang out. Thank y'all for being here and being friendly and keeping it a place where we all feel safe and good to be. And of course, Rachel, thank you for editing the show. And I want to thank absolutely our Patreon sponsors for their sponsorship of this show. Thank you to Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Cowles, Kent Northcote, Rick Loveman, George Corris, Pierre Velazarb, John Ratnaswamy, Carl Kornfeld, Chris Wozniak, Verigard, Chef Stad, Donathan Stiles, a.k.a. Don Stylo, Ali Coffin, Reagan, Sarah Forfar, Don Mundus, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredus 104, Sky Luke, Paul Ronovich, Kevin Rudin, Noodles Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Johnny Gridley, Clemmy Day, G. Burton Lattimore, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkon, Kevin Parachan, Aaron Luthen, Steve DePel, Bob Calder, Marjorie Paul D. Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you for all of your support of TWIS. And if you are interested in supporting us on Patreon, head over to twis.org and click on the Patreon link on next week's show.
We will be back Wednesday, 8 p.m. Pacific time, and again Thursday, 5 a.m. Central European time, broadcasting live from our YouTube and Facebook channels and from twist.org/live.
Want to listen to us as a podcast? We hope you already are, but if you're not, you can look for This Week in Science wherever podcasts are found. And if you enjoyed the show, get your friend to subscribe on their podcast machine also.
For more information on anything you've heard here today, show notes, links to stories and studies will be available on our website, www.twist.org. You can also sign up for a newsletter.
And we will mail one someday. And you can contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Or in all of this, if you want to make sure that the email gets to us, make sure that you put TWIS into the subject line of the email so it doesn't get spam filtered into a beehole that was containing pollen that's not really from a flower. You don't want your email in a beehole. Come on. Never see it. You're welcome.
Pun got your tongue? You can also hit us up later. I think we're still on the X box. TWIS at TWIS Science, at Dr. Kiki, at Jackson Fly, at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
And we will be back here again next week. We hope you'll join us again for more great science news.
And if you've learned anything from this show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. This Week